Hello, wonderful people. Um, this isn't a normal session. What happens is we are still in the works. We are looking for ways you can leave this planet. We saw Marie Curie's message, and then we are working on triangulating the location and then finding it, and also finding the device. It turns out she sent us a message that the devices that triggered us to come in here are also here. Yeah, hairs and eyes. So we are going to get ours in a heist. Don't worry, that will happen in the next episode. But then for today, as you can see, we are all in our dying days. We've been miserable for the past 3 weeks now of our stay here. We hardly eat, and the little we had on ourselves, we managed to buy the same clothes that we had on our universe. Okay, so yeah, Omar is there. He's busy. He's working on the triangulation, and I just needed to spare some time to come and talk to you guys. Yeah. So today we're talking about the Big Bang Theory. We can be talking about the multiverse theory without the Big Bang Theory, and yes. So what the Big Bang Theory is about? To begin, there was this priest, George Lemaitre, and he was one of the first theoretical physicists that noticed that space was expanding. Yes, so you can say that he's one of the earliest scientists that proposed the Big Bang Theory. Yeah, a priest. So the Big Bang Theory, the universe as we know it, started with an infinitely hot and dense single point that inflated and stretched. First, at unimaginable speeds, and then at a more measurable rate. The cosmos still expands till today. The expansion that occurred instantly during the inflation period of the Big Bang is believed to have been faster than the speed of light. A flood of matter and radiation, known as reheating, began populating the universe. That's the electrons, the protons, the neutrons, all these fundamental building blocks built up and clumped up to become what we see today. To ascertain or to confirm a Big Bang Theory did exist, there are a few things we should take note of. First, we start off with background radiation. Background radiation, say according to calculations, the heat energy that was erupted from the Big Bang had been spread out across the universe, and this was the background radiation from immense heat to microwave heat. Existing technology has not been able to make scientists like us peer into time of the birth of the universe. But this concept of cosmic background radiation, amongst other mathematical formulae and models, proves this proposal. Background radiation was discovered when scientists Arno Penzias and Robert Wilson picked up overwhelming temperature readings from their radio receiver. When they are trying to create this radio receiver, they had these interruptions. At first, they thought they were pigeons pooping on their receivers, and then they did justice to them. But then later, they realized not the birds or any other influences, but it was from outer space. The proof of the Big Bang is the Hubble telescope, another one. And it shows the distancing of objects from us at a rate proportional to their distance. So you can see that objects are moving faster away from us proportional to the distance from which they are. So you can see one galaxy moving away from another at a faster rate. Yes. But then what you take note of is that these entities in one galaxy, the distances between them don't really begin that much. It is the distances between galaxies, between spaces, that is expanding. That's taking the diffeomorphism invariance into consideration. The properties of cosmic background radiation showing transition from plasma to neutral gas etc. Cosmic background radiation is what proves the existence of dark matter and dark energy. This is because there are aspects of the universe plotted by cosmic background radiation map that is devoid of energy or matter, but some way somehow they affect gravity but not light. The Big Bang wasn't really an explosion, it was an expansion of energy becoming mass, forming gravity, while the energy traversed in the form of radiation, including light. Another thing that proves the existence of the Big Bang Theory was the redshifts of stars. So, the idea of redshift is simple. When taking Doppler effect, when a vehicle is approaching with a siren, right? The faster or the closer the vehicle appears, the louder we hear the siren, the sounds of the siren. That is how these redshifts work. But then, in terms of light, the faster these cosmic bodies approach us, the more intense the lights they transmute, right? So this is the proof of redshift of stars. The redshift of stars is the moving away or the shifting away of these heavenly bodies. When they move away, their wavelength increases, and red has a higher wavelength than all the colors, right? When they approach us, there is a blue shift, and that is when the wavelength has decreased enormously. The period of inflation states that when the universe was about to be born, the four fundamental forces, being gravity, nuclear force, strong force, electromagnetic force, were indistinguishable. As the universe started to expand and cool, these forces began to behave differently, causing a sudden release of energy and triggering the rapid inflation. The period was so fast, it occurred in a fraction of a second. Stephen Hawking explained that the edge of the universe isn't the end of the universe. It is curved up, just like viewing the South Pole. Like asking yourself this question, what is south of the South Pole? Just like how you see the earth, or you see a horizon of the sea. You can't see its end. You can't really reach its end. That's how the end of the universe is. So maybe you can picture the universe as a globular structure. Yeah, right. And then maybe we delve into Einstein's theory of relativity, which also proves, to some extent, the existence of the expansion of the universe, which he accounted in his very beautiful formula, the Einstein's general relativity formula. Yeah. Other theories that also backs this Big Bang theory is the Big Bounce theory, which specifies the Big Bang being an expanding theory of the universe, and a Big Crunch theory, which describes the contracting nature of the universe. When there was a universe which contracted, teleported, and then expanded again to become this known universe. So, according to this theory, the universe existed before the Big Bang, but then it reached a state where it bounced, crunched, and then bounced again for us to notice this universe. So, in any case, this universe will crunch when it reaches some point, and then it will bounce again, and that's the theory of the big bounce and the big crunch. Now we also enter into the conformal cyclic cosmology. It's an assumption in the neighborhood of the crossover regions between cycles allows space-time to be related to successive conformal rescaling. Conformal geometry, where we lose track of scale. A huge cold universe is the same as a hot small one in its beginning, meaning the Big Bang was the beginning of a new universe resulting from the end of an already existing or expanded cold universe. So this supports the Big Bounce and the Big Crunch, where we say that the scales doesn't matter, the universes are the same, but that it was extremely big, like we are expanding into, or extremely small, like where we started from. The universe is contained in itself no matter the scale. Yes, that's what supports the expansion theory per se, because everything in this universe right now was in that teeny tiny point at the time of the Big Bang. And then there is even a stranger theory called the strings theory. And this strings theory brings up the idea that hyperspace exists in hyperspace. What this means is that it's like an entity, a mind entity, where there are different dimensions. So the string theory brings about the theory of dimensions. When you look into the superstring theory, it gives you that there are 11 dimensions in this known universe, and these 11 dimensions came together. There was an energy release, and this energy release from each of the collisions of the 11 dimensions created what we know today as the Big Bang. Yes, so this and many more are the theories that supports the Big Bang theory. Okay, so that's just all what this is about, the Big Bang theory. Yeah, I hope you've enjoyed it. You've learned a lot as you are waiting. Omar is supposed to come here to come and give you fun facts, but then he's busy, and I'm bad with fun facts. So don't worry, next time we'll give you two. Yeah, so ciao. Until next time. Bye bye.